So welcome to the session of Electric and Hybrid Vehicles Module 1. In this session we will be discussing about vehicle dynamics and tractive effort. So today we will see the fundamentals of vehicle dynamics. And the most important term associated with the vehicle dynamics is the tractive effort. So what is this tractive effort or tractive force? This tractive force is a force that a vehicle needs to propel in the forward direction. Why this force is important is that when a vehicle moves in the forward direction, there will be a lot of resistive forces or opposite forces which are acting on the vehicle. And only if the vehicle is having sufficient force to overcome those resistive forces, and also if it has the force to accelerate, then only the vehicle can move in the forward direction. So the sum of all these forces that a vehicle should possess to overcome this resistive force and to accelerate in the forward direction is called as a tractive effort or tractive force. So first we will see what are the resistive forces acting on a vehicle. So for that, consider a vehicle, and you can see a vehicle is moving on a slope having an angle psi. It is also in some textbooks you can see it as alpha. And here when the vehicle is moving in the forward direction, so many forces are acting in the opposite direction, and those are called as the resistive forces. So first resistive force is a rolling resistance, and this rolling resistance is a resistance that is acting by the tire on the road, or it is due to the rolling of this tire on a surface. And this is a type of frictional force which will prevent the forward motion of the vehicle, or it opposes the forward motion of the vehicle. And that is represented by the term FRR, that is force due to rolling resistance. Now next is the aerodynamic drag force. It is again a resistive force, and this force, which is represented by FAD, is due to the opposition of the friction which the air or the surrounding wind or air which is providing against the vehicle. It is represented by FAD. And then comes FHC, or this is called as the uphill resistance force or hill climbing force or grade resistance force. And this component or this resistive force occur due to the vehicle moving. If the vehicle is moving in the inclined plane, the weight of the vehicle, there will be a component of weight of the vehicle which will be acting opposite to the motion of the vehicle, and that is represented by FHC, or the uphill resistance or the hill climbing resistance. And also if we need to accelerate the vehicle, or if we need to increase the velocity of the vehicle, then an additional force should be there within the vehicle, then only we can just accelerate the vehicle. So only if the vehicle is having sufficient force to overcome this resistive force, and if it is having this particular accelerating force, then only the vehicle can move forward or accelerate in a particular with a particular velocity. And the sum of all these forces together is called as the tractive effort or the tractive force, and it is a force which helps the vehicle to move forward or to propel in the forward direction. So now we will see one by one these resistive forces which is playing an important role in the tractive effort. So now we will see the rolling resistance force. So this rolling resistance is a force that must be overcome by the vehicle to roll a wheel over the ground. We can say that this is actually a type of frictional force that happens when a wheel or a tire is moving, or it is rolling on a particular surface. So we'll see what is the expression for this rolling resistance force. Consider a vehicle which is moving in this particular direction on an inclination alpha. So you can see that if this angle is alpha, obviously this particular angle will be also alpha. And here this line or this vector, it shows the weight of the this particular vehicle which is acting directly downwards. So if this angle is alpha and this is a weight, then we can just resolve into two components, that is this will be W cos alpha and this will be W sin alpha. And when we check the frictional studies, it shows that if we are having a component which is acting normal to the surface, and if the vehicle is moving in this particular direction, then the frictional force or the rolling resistance force which is acting opposite to the motion of the vehicle is given by FRR, where FRR is equal to mu or mu RR into this component of the weight or the component of the force which is acting perpendicular to the surface. So here the component which is acting perpendicular to the surface is actually W cos alpha. So we can write it as FRR is equal to mu or mu RR into the perpendicular component which is W cos alpha, where alpha is the angle of inclination and W is weight which is given by m into g. So in short, we can write the expression for the force due to rolling resistance as mu RR into mg if there is no inclination, or if there is inclination we can write it as mu RR into mg cos alpha, or it is same as mu RR into mg cos psi. So psi or alpha represents the angle of inclination. So this represents the force due to rolling resistance, and this is a type of opposition force which is acting against the motion of the vehicle, and the tractive force of the vehicle should overcome this resistance due to rolling resistance, then only it can move forward. So we have seen that this rolling resistance force FRR is equal to mu RR into mg cos alpha or cos psi. And this mu RR or the coefficient of rolling resistance, it in turn depends upon many factors like tire material, tire structure, temperature, then inflation pressure, then geometry, then road roughness, etc. For example, even if it depends upon the type of the road. If you are having a smooth road, then the value of rolling resistance will be very less. Or in an iron rail, you can see the coefficient of rolling resistance, that is mu RR is having a very low or a less value. But if we check for loose sand, you can see it is about 0.15 or to 0.13, or in a bad earth tracks or non-paved roads, its value will be high. So if mu RR is high, then FRR, that is the force due to rolling resistance, will be high. So only if the vehicle is having that much extra tractive effort or tractive force, it can move forward. So that is why it is very difficult to move in a loose sand than in a very smooth surface of road. So the next type of resistive force is an aerodynamic drag or aerodynamic resistive force. So as the name suggests, this is a force which is due to the friction of the vehicle body which is moving through the air. That is, when a vehicle or any body moves through the air will be providing a particular frictional force against the motion of that particular body. So that frictional force is called as a aerodynamic drag. And it is given by the expression FAD, aerodynamic drag resistive force, is equal to half into rho into A into CD into V square, where rho represents the density of the air and usually taken as 1.25 kilogram per meter cube. And here A represents the frontal area of the vehicle, that means what is the frontal area of this particular vehicle. And CD, it again represents a drag coefficient, and this drag coefficient will be different for different types of design of vehicles. And V in turn, it represents a velocity of the vehicle. And sometimes if there is also a wind speed which is represented by VW, then that wind speed component should be also taken into account, and then the equation becomes half into rho into AF. AF is same as A, which is the frontal area, into CD, which is the drag coefficient, into V plus VW the whole square, where VW is actually the component of the wind speed. And if that wind speed is moving in the direction of the vehicle, it has a positive sign, and when this component is opposite to the vehicle speed, it has a negative sign. So this is the expression in turn. This is the expression for the aerodynamic drag force. And as we told, the value of coefficient of aerodynamic drag CD in turn depends upon the type or the design of the vehicle. For example, if you take an open convertible vehicle or a vehicle like this, it will be having a very high value of aerodynamic drag, that is from 0.5 to 0.7. Whereas if you just go for a particular optimum streamline design and all, you can see its value is just 0.15 to 0.2. So by designing or by better designing or by optimum design of the vehicle, we can actually decreases this aerodynamic drag coefficient, or in turn we can reduces the resistive force due to this aerodynamic drag. Now coming to the components of aerodynamic drag, it is actually as a result of two effects or two components. First one is a shape drag and the second one is a skin friction. So what is a shape drag? When a vehicle is moving in the forward direction, actually the air in front of it, the air cannot instantaneously move out of the way. So here there creates a high pressure region. Okay, so this is a moving direction. Similarly, the air behind the vehicle, it cannot fill the space behind the vehicle, and there create a low pressure. So here there is a high pressure region and here there is a low pressure region, and what happens as a result of this different pressure zones, what happens is that this will create or the vehicle will be pulled backwards as a net effect. Or vehicle is pulled backwards means we can say that this effect is actually creating an opposite force to the motion of the vehicle, or it is creating an opposite force against the moving direction. So that is what is called as a shape drag. And skin friction means that when we take a vehicle moving in this particular direction, the air which is very close to this vehicle, that molecules will be moving almost with the same speed as that of the vehicle, while the air molecules which are far away from this particular vehicle, that will remains still. That means in between, these air molecules will be moving at a wide range of speeds. And this difference in speed between the two air molecules, that is a layer of molecules which is very close to the skin or the surface of the vehicle, as well as the air molecules which are away from this, and this difference in speed between the layers of air molecules, it produces a friction that will in turn results or in turn opposes the motion of the vehicle. So that is called as a skin friction. And this aerodynamic drag is mainly due to this shape drag and skin friction. Now next comes a third type of resistive force, which is called as a hill climbing force or the grading resistance. And as I told, this is mainly or this happens when the vehicle is moving on an inclined surface. So consider a vehicle having a weight which is mg and is moving on an inclined surface alpha, and that is alpha is the angle of inclination. So if I take this mg as a weight component, I can resolve, as I told, this is alpha, then this will be of course alpha. I can resolve it into mg cos alpha and mg sin alpha. And you can see this mg sin alpha, that component of the force or that component of the weight will be acting in this particular direction. That means this component of weight will produces an opposite force to the direction of motion of the vehicle. And if you check, if the value of alpha is 0, actually this mg sin alpha term that disappears, or that also becomes 0. So in turn, this component occurs only if the vehicle is moving through an inclined surface. Okay, so this inclination or grading of the surface in turn causes an opposition force to the against the motion of the vehicle, which is represented by mg sin alpha, and this force, resistive force, is called as the hill climbing force of resistance or the grading resistance force. So we have studied this FRR, which is a rolling resistance, force due to rolling resistance, and FHC, which is a force due to the hill climbing or the inclination. And if we add these two forces together, this particular force is called as the road resistance force, which is represented by FRT, and that is equal to mg mu rr cos alpha plus mg sin alpha. If you take the mg term outside, it becomes mg into mu rr cos alpha or psi plus sin psi. So these are the three resistive forces acting against the motion of the vehicle. And we know that apart from overcoming this resistive force, only if the vehicle is having a force to accelerate, then only it can move or it can accelerate with a particular speed. And that particular force is given by the expression, you know, that force due to acceleration is equal to m into a, where m is the mass of the vehicle and a is the acceleration. So acceleration can be also written as dv by dt. So it should be actually m into dv by dt. But you can see a particular term also here, which is represented as summation or sigma j rotational by r dynamic square. So what is this j rotational is that it is the inertia of the rotational components. And what happens is that not only the total mass of the vehicle, but the initial mass of the rotating parts, that is represented by j rotational, that also when the drive is accelerated or braked, that also will cause us a force due to acceleration, and that is represented by sigma j rotational by r dynamic square into dv by dt. If you remember, in the rotational motion we used to represent by, I think, I. So this I will be usually represented as I is equal to m into r square, where r is the radius. So this is actually a mass again, which is represented by I by r square, or here it is represented by j rotational. So j rotational by r square radius. And what is this r dynamic? This r dynamic is actually the rolling radius. What happens is that when a vehicle or when a tire is or a wheel is made to roll on the ground, there will be a change, small change in its actual radius. This will be different for different surfaces, depending on different conditions. This will be different, but there will be a change in the radius, effective radius of the wheel, and that effective radius is taken as r dynamic or rd in certain textbooks, or we can say that the effective radius, effective rolling radius. Okay, and this is the actual radius. So this r dynamic or rolling radius or rd all represents the effective radius. So I can write the force due to acceleration or acceleration resistance and force is given by Fa is equal to m plus sigma j rotational by r dynamic square the whole into dv by dt, where dv by dt is our acceleration. Okay, so this is actually a mass again. So the total mass of the vehicle plus the initial mass of those rotating parts, that together into that is a total mass into acceleration, which is dv by dt is the force due to acceleration. Okay, and sometimes we will just represent it like if you just take this m outside, you can write it as m into 1 plus sigma j rotational by m into r dynamic square. That is this particular term, that is 1 plus sigma j rotational by m into r dynamic square, that is represented by delta, where delta is a mass factor. So if we represent this particular term by delta, I can write this expression also by using this equation. Fa is equal to delta m into dv by dt. The same thing, where delta is called as a mass factor. Thus, we have seen the total tractive effort is actually a combination of all this resistive forces and the force which the vehicle need to accelerate. So, Ft or Fte, both are same. Tractive force or tractive effort is equal to total tractive force is equal to FRR plus FAD plus FHC plus FA, where FRR is a force due to rolling resistance, FAD is a force due to aerodynamic drag, FHC is a force due to hill climbing or the grading resistance force, and FA is the acceleration force. So if you just substitute FRR as mu RR mg or mu RR mg cos phi or cos psi or cos alpha, FAD as half rho A CD V square, FHC as we have seen mg sin psi or sin alpha, and FA as this m plus sigma j rotational by r dynamic square into dV by dt. You will be getting the total tractive effort of the vehicle. Okay, so this represents the total tractive effort of the vehicle. And here this m and this m represent the same thing, that is the mass of the vehicle. And from this, if you calculate the acceleration, which is this particular term dv by dt, then you can write dv by dt is equal to the tractive force minus the resistive force by this delta into m. We have seen that this particular term can be written as delta into m into dv by dt. So from this equation, you can write dv by dt as this tractive force minus all its components divided by this can be replaced by delta m. Okay, so that is why it is written as ft minus all this resistive force divided by this term m plus sigma j rotational by r dynamic square, or this can be written as same as delta into m. Okay, so this is expression for the total tractive force and this is expression for the acceleration. This you have to remember.